This
now,
conference will now be recorded.
and I'm actually, usually what happens is the first 5-10 minutes are people strolling in and selecting and connecting. But I'm still going to take advantage of this time because your time is precious to me. And it's good to
Hi,
see
Serene.
Serene on the call.
Hi, Serene. Long time no see. AC here. Remember me? Wow, it's Serene. You sound like Dalek.
Serene, you're not coming in.
Serene, you sound like a Dalek. An angry Dalek. so,
So
I
I muted you briefly here, Serene, because
yeah.
it was really loud, but I don't want to mute you too much longer. I'll take you off mute. There you go.
Hi, can you hear
That's
me?
peaceful.
Yes, we can.
We hear you fine.
Much better.
Yeah.
Okay. Again, I expect people to be strolling in. Serene, it's good seeing you. It's jeepers. Been a while. And I'm going to share some screens here real quick. Kind of an introductory kind of move in as we start this call. And hopefully most of you understand or have heard of Open Compute Project. But I first heard about Open Compute Project about 11 years ago when I was with a company called Schneider. And at the time, I saw them as being a threat to everything that Schneider did. They were making commodities out of what we made high-priced items out of. But I've learned to grow, and actually Schneider is now a partner of Open Compute. In essence, Open Compute, founded by Facebook and Rackspace and a couple others, I believe Goldman Sachs as well, has grown, and its membership includes 250 different members, including those that you see on board, Microsoft, Google, and Schneider, and Vertiv, and Cheora, Alibaba, Baidu, Spiritus, and many more that I'm not going to run through on this call. Last year, well, they've grown beyond just enabling IT in the rack. We've grown beyond just enabling IT in the rack. And there's a lot of projects that are going forward to try to enable the deployment of IT. And sometime in the past, we moved toward, there was this initiative to add liquid-cooled IT into data centers. And there was advanced cooling solutions, which looked at cold plate. Just kind of give you some ideas. You have door heat exchangers, cold plate, and immersion. And none of these technologies are especially new. They've been used for decades. But what we're finding is there's a phenomenon of people are building air-cooled data centers, and they live in fear or concern that someday in the future they will have to add liquids. And I've spoken to most of you at most of your companies at different points, and this is something that's being looked at now. And so last year, Advanced Cooling, or the Open Compute, invited the creation of a new sub-project, and that's looking at an Open Compute facility, advanced cooling facilities, basically to develop global best practices, collaboration, common guidelines on adding liquid-cooled IT into data centers. Now, is that what the people that are on this call right now, is that what you were hoping to hear more about, or is that something that are problems, or what are your thoughts on where that fits? Darren, see you clicked your mic on and off.
Yeah, that's what I'm
No,
looking
I'm
for.
good. Yeah, that's exactly what we're looking for, and just to see what's the future as well, where we're heading to.
Okay. What you'll see if you go back to that list of participants, these guys have been many people have been making liquid-cooled IT for decades. But what's changed is the specter of adding liquid-cooled IT to the data center of today, which to a large extent, many situations, is a slab floor And it's typically designed around air-cooled IT with the thought someday in the future we may add liquid. To make that simple, there's a lot of simple things you can do to make that possible. And what we've been doing on the other side of the world is we've been having these weekly calls and subcommittees, and we've broken out a couple different case studies. We have these concept designs, which have been done out in Revit. And here's one concept design where you're taking two coolant distribution units, supplying a roll of say, cold plate, and tapping off an existing chill water solution. And then what you have over here on the right is the same concept with rear door heat exchangers. And then in the middle, we kind of took a different approach. We looked at the fact that if you're working with immersion cooling, you may not even need to tap into a chiller plant at all. And you may actually start looking at either tapping to your facility water solution, or you may just tap directly to a loop that goes outside on heat exchangers. A couple things. I'm going to change screen here real quick. At least I think I'm going to. Let me unshare. Stop sharing. Let me go back and share screen. And let's see if I can do this right. What I was going to do is show you here. This all, and everything we talk about is actually open. That's why it's called Open Compute. And they're actually, if you go to the Open Compute web page, you can click on here, and on the Open Compute web page, we have wikis. And on those wikis, they talk about how to participate. And membership is fairly easy. You can attend and participate for free. You can become a member and contribute, and that for a company to contribute is like $2,500 a year, up to some of those people you saw are paying much higher rates, but that's kind of the community member level. And then you have these different groups, and then under the facilities group, data center facilities, we have this advanced cooling facilities group. And if you go here, you'll find that I have a co-leader who's a little bit late. I think he's gone to bed maybe. But we have a wiki. And the wiki actually has links to these work streams that are coming. And the work streams are being contributed to by a fair number of senior people in the industry. Kind of jumping back to the PowerPoint I was showing before. I'll change this format here. And some of my team include Valley Sorrell from Microsoft, John Musilli from CPS. He used to be the head of Intel's data center team, or at least their mechanical. John Gross is a fairly progressive engineer in Texas, who's actually done a fair number of deployments of exactly what we're talking about, adding liquid in an existing data center. We're going to have a panel discussion here. Back in the United States, they're starting to open these things called trade shows again. And then Data Center World is another trade show that's going to be featuring some of these discussions. We're actually doing a workshop. But getting back to the focus of this team, the mission of the advanced cooling facilities isn't to preach about the benefits of these advanced cooling solutions. We're kind of letting the vendors and the sub-projects associated that preach that. And they'll talk about efficiencies and high density and sustainability. What we're really trying to do is reduce the barriers to ACS, the barriers to advanced cooling solution. The number one barrier is a perception. The barrier that it's risky to run liquids in this environment. And I would also say that not that many years ago, very few people would have run pipes right over their racks. But I can tell you today, that is happening. And one of the things we're trying to do to try to enable that is, as I mentioned, our job, the old ACF, is to develop vision, show best practices and success, reduce cost via standardization, reduce complexity via simplification. Let me pause here. Am I going in a direction that people want, or it seems like I'm kind of preaching, and I really don't mean to preach. I just kind of want to invite people to see what's coming down. Any questions from the audience? Where do you see challenges in the data center? Where do you see is the world out there ready for liquids being added to a slab floor data center with pipe over their racks? Any takers on that one?
I think
AC.
Don, that's definitely Josh from AirTrunk here. I think that's definitely the one challenge is and I haven't had a chance to read through all the material on the wiki yet, but you know, getting pipes out there, and I'm assuming Victolic probably has solutions for this. Getting pipes from you know, potentially wet areas out to the server hall floor is the challenge mostly. Is that covered already on the wiki?
Well, so we can, and short answer, a couple things. I'd like to, as much as possible, and I do appreciate there's some hypocrisy here, potential hypocrisy. I do work for Victolic, but I try to make sure that I surround myself with a team of trusted advisors that keep me on focus. And this is not a preach on Victolic. This is actually, everything you're seeing here is something that was done with a group of very sophisticated engineers, and we can come back and talk about that. But short answer is, yes, there's two different work streams that we're looking at that we've developed. One work stream is, and when I say developed, these are currently, and I started to show you the links to them, there's guidance, standardized methods of connecting liquid-cooled IT to cooling loops. And here we're actually looking at the connection. And then the other was coming up with reference designs. And the concept behind a reference design is to try to incorporate as much of the content that you're possibly going to be having to add to make sure that you have done so. So right now, we do have Revit documents, for example, that these are Revit printouts or Revit design. One of the future steps that we're moving toward is taking one of these printouts here, and one of the requirements that we're asking for vendors is that all vendors of OCP, liquid-cooled IT, will provide content in a defined Revit. And we're still working on how to communicate that, because in the United States, we talk about LOD 350. Is that a term that's familiar down in Australia or
Absolutely.
Singapore?
Absolutely.
Okay. So I've heard some people from Europe, they have a different BIM standard. But what we're saying here is that the key thing to look at here, what our vision is, to enable this. We would love to go from reference design, from concept to drawing, to bill of materials, to prefab kit, to installation without hot work. Snap it together, make it into a Lego kit or an IKEA kit or some sort of construction project. And that, the concept of perfect prefab at the speed of thought, it may be a little bit energetic, but we see it as a potential if certain requirements are met. Number one, that you have a decent drawing to begin with, something that shows the concept. So, for example, if you're putting in a data center, you should at least know that if consider whether or not you're going to use coolant distribution units. And if you're going to use coolant distribution units, then you need to have a space for the coolant distribution units. And you need to understand when or where and why you'd want them. And what you're looking at this one here, this is a kind of a mishmash of cooling, because what you're seeing here is a little bit of immersion tank, maybe some rear door heat exchangers, a cold plate. But fundamentally what you have, the number one thing you need is some sort of tap offs on your supply line, with some sort of plan for space for the pipe to run.
Just a thought.
And
it is AC here, just a thought.
yes?
There's still a lot of data centers in Asia Pacific that still uses raised floor, even though I think over time in future it may be less and less. I was just thinking out loud because you know, we can. I mean, that raised floor usually is only for you know, transmission of air. So I was just thinking out loud. Maybe perhaps that we can still do the do the water pipes, but we can do it, you know, under the raised floor, you know, and then perhaps able to trap any leakage from water. You know, the reason why I'm saying this is because if we're still doing a data center design, I may have to unfortunately still do some data centers with raised floor. You know, I was just thinking out loud. I know it's sort of kind of,
Absolutely.
but yeah, just think out
So,
loud. That's all. Yeah.
so I've been involved with data centers about 20, 21 years. And in that time period, one thing I have learned is that there is no space in a data center that's protected unless you protect it. So what does that mean? A lot of people put in raised floors thinking that that's where they would distribute something. And then after about 3 or 4 years, they went back underneath the raised floor and they found out that there was stuff down there. People put in other things. And so there's nothing wrong. In fact, raised floor, we're not prescribing one or the other. We're actually trying to take maybe a worst case scenario, because in all honesty, to drop this pipe down below the raised floor, there are BIM tools that can do that very quickly.
Yes.
Let's kind of look at, this is one area that I think is a very popular discussion. One of the areas that I really feel passionate about is this dew point and avoiding it, okay? Because I would say 90% of the stories or fears about data centers wasn't that the pipes leaked. It's that water dripped from the pipes and people said the pipes are leaking. But in many cases, the pipes leaked because someone broke a vapor barrier, or somebody didn't pay attention and you might have had some corrosion. The reality, does that make sense?
Yes, but I was thinking also, water dripping from the pipes may cause ponding, you know, somewhere, and then people may slip and fall down and hurt themselves. You know, that's my other thinking process. And
that'd be a good reason to still put the pipes underneath the floor. But one thing that we're finding with these, a lot of these solutions here, immersion tanks. You can actually cool immersion tanks with 45 degrees centigrade liquid. And cold plate, you can cool those with 35 to 45 degrees. And there's very few places where 45 degrees centigrade will give you condensation. At least not, I think even in Singapore, 45 won't get too much. Maybe someone can comment on that. But you're above the dew point in most regions, and pretty much every region. And so one of the discussions that came up, we'll jump back and forth, was this concept of coolant distribution units. And the concept, some people, you know, what is a coolant distribution unit? And in some data centers, people use coolant distribution systems where the entire facility, you'll have pumps and heat exchangers, and that may be what connects you to some sort of cooling source. For example, if you're using say a seawater cooling solution or something, you may have a heat exchanger that will then tap off and you'll run different loops. A lot of the ITE people are coming up, the liquid cooled IT are coming up with smaller units, either in form factors for racks, in form factors at the end of a row of racks, or they may put a little room here, okay? One discussion that came up is if you're looking at, if the only thing you need to do with a CDU is to raise the temperature of your facility water to above dew point, that can actually be done with a 3-way valve. And this was a discussion we just had the past 2 weeks. The concept of if all you're looking at doing is trying to protect the keep the liquid going to your immersion tank, for example, above dew point, you could tap off a 20-degree centigrade line or 10-degree centigrade line, you can put in a heating loop, and then you can actually use that to distribute liquid, and you won't get condensation. Let me pause. Does that make sense to anybody? Would anybody ever do that?
I think in an instance where we're actually running low temperature water, which is becoming increasingly uncommon, it makes sense, and I've seen that before. That's a good way to get the temperature up above dew point, and probably get the temperature closer to what the field equipment actually wants. But I mean, I don't know how many new data center facilities are running, you know, sort of ice cold chilled water these days.
well, but I appreciate that. But what happened was we had this discussion, just kind of doing the what ifs, and we said, you know, do you really need to put in a CDU because what I'm saying here is in many cases these IT racks may have a CDU built inside. There may be a heat exchanger. You're not going to want to run facility water through a cold plate. Cold plates are not designed for the pressures or the water quality of facility water. But you may want to take facility water and run that through the CDU that feeds your cold plate. And there's a chance that so we just put this in the toolkit this past week of, if you do happen to be working with a data center where there is a very cold water supply and potentially that goes below dew point, the things you could do. The other, kind of flipping this back around, this concept here could also be used in this situation where, come on.
Yeah, the free cooling using the outside temperature can be very cold,
Exactly. So if you have an outside temperature here, there's two things you may want to use. One is you may want to actually use something to keep your line from freezing, to actually have the heat from your data center keep your heat exchanger from freezing. And you could use the same concept, this three-way valve, to balance that out.
So
in many situations, yes.
So sorry about that. I mean that whole pumping three-way valves, it's more like you typically use on a coil where you have a freeze protection type arrangement.
Yep.
But with that setup, I'm not sure that's piped up correctly though, because if you're modulating the three-way valve to bypass a certain amount of flow back to the main system or bypass a certain amount back to the CDU loop, that means your pumps got matched that bypass GPM or flow rates. So now you can control the pump flow rate and if you have flow rate to match. That seems a little complicated to do.
So you're bringing up a great point, and let me kind of say one of the things that I'm doing today. I don't mean to be preaching as much as summarizing where we're at in discussions. This topic we had today was something that came up the first time a week or so ago. There's a lot of refinement needs to be, and this is where one thing I would like to jump back to is this here. These documents are collaborative documents. So if you go here, and I haven't go to the, say, reference design document, which is very much a rough draft. And what the purpose is called, more than me to preach, is me to appeal to open contribution. And one of these guys, this guy, Mark Lomers, he's from Down Under. He went through and added a bunch of comments to this. So as we go through here, we look at the table of contents and we look at some of this thing, and we are still building this guidance. So today isn't preaching, it's really sharing what was discussed earlier today and talking about, so case one, existing loop, and having people edit and continue to develop this. This is one of the questions that came up by people was, well, how big a pipe do you need? Well, that depends on how big a delta T and how big a KW you need. But just for simplicity's sake, we gave up, ASHRAE has some flow limits. And so this whole purpose of this drawing here is just give people a feeling that, okay, if you're looking for, say, a megawatt of liquid heat, then you, with a 10-degree delta T, you could get close to that with, say, a 6-inch pipe, okay, or 150 DIN. So these are things that are happening here. Again, the purpose of this call, what I really love out of this call is to inspire somebody to be kind of a co-lead for Asia Pacific, because I really feel bad when we have this OCP project where every week we're talking about it in the United States and in Europe, and then good old AC Lee, he gets up in the middle of the night or whatever and joins in as well. So I'm trying to figure out how to balance that out. Did that answer your question?
Yeah, I think it does. Thanks, Don.
Well, so Alan, I would definitely. Is this something you'd like to be contributing more to? We do need some good engineers on this program.
We can talk chat.
Well,
I just recently relocated from US over to APAC region, so I'm still in mixed time zone at this point.
Okay. So where are you based right now, Alan?
I'm in Taiwan right now.
Okay.
So I'm in
as
the
we
APAC
go
region.
through here, right. So as we look at here, there's some other references in this document right now to help people understand where dew points are and what ASHRAE's recommendations of dew points. And then it kind of goes on through, and then we have a case 2, which is the elevated temperature loop. And AC, I think you're doing both elevated temperature and a facility water solution, chill water solution, aren't you?
Yeah, so yes, correct. So mine's a dual loop system. So first one will be using the chiller plant, traditional one, using a high water temperature, roughly about 17 degrees. And then the other one is using ambient, using dry coolers or close to cooling towers. That one can be varies quite widely. That one can be as low as 2 degrees. No, 4 degrees. So it's pretty wide. Yeah.
Okay. So that's where we're looking at here. And as we start looking, you saw this picture before, and for some reason it's kind of hanging up a little.
So
but what you're looking at,
yeah.
So here we're looking at just kind of a layout where, and one of the things with the elevated temperature loops is immersion tanks. You'll hear many of them. They're developing solutions for IT up to say 60 degrees centigrade. And at 60 degrees centigrade, one of the questions kind of comes out: can you do something besides just dump the heat out to the environment? Can you do something productive with 60 degrees centigrade liquid? And I don't know. On a small answer, that's true. I mean, if you have 500 kW of 60 degrees centigrade, you can find out something to do with that. When you have 30 megawatts of 60 degrees centigrade, it's
too much.
It takes a lot.
Yeah.
Well, unless you have a facility. Does that AC? Have you looked at this?
No, yeah, kind of. Because the data center have located kind of cold. So, for example, we actually tap off some of the water loops to cool, heat up, the office block that's nearby actually. All right, but there's only a certain amount of heat that we can take away. Like what you mentioned, a couple hundred kilowatts, no problem. I can definitely use it up to heat up office block during winter time. All right, but 5 or 6 megawatts, the problem is that the heat is low grade. All right, so we can't. The only way we can make better use of it is to somehow increase the heat temperature. Unfortunately, most of the heat we eject out is max out at 30 plus degrees. All right, so it's not.
Right.
It's not high grade enough. So maybe I was just thinking out loud. We're using thermal. We're using solar panels. Even during winter, the solar panel can heat up some part of the water. Maybe you can do heat up that water even further. But it's something that's fruitful thoughts. I don't know.
Well,
maybe
so in some.
maybe heat up enough.
Here's the deal. There are parts of the world up in Stockholm where they are using 30 degrees centigrade and they are doing district heating and they're coming up with some models. But one of the exciting things is immersion cooling may actually open the door for more applications. And the
How hot
world
does that go?
seems to. What's that?
How hot does the water go actually for immersion? Does it go very hot?
Well, immersion can sustain and protect chips at 60 degrees centigrade. So they can exhaust at 60 or 70 degrees centigrade in some situations. Okay. Now, having said that, there's another group, and both in ASHRAE, and we don't compete with ASHRAE. OCP works with ASHRAE, but what you're looking at there, the other group is looking at chip performance at different temperatures, and so some chips perform great depending what their functionality is at 70. Some their clock speed might be limited a little, so they may want to limit it to say 50. But even 50 degrees centigrade liquid is better than 35 degrees centigrade air or 30 degrees centigrade liquid for some sort of applications. And the purpose of this discussion, in all honesty, I'm not trying to adopt heat reuse as part of this committee. There's too much we're trying to do already. But it is a concept that will be coming and is coming. And in Northern Europe, it's definitely taking on. And as we come up with ways to use higher temperature, more and more people are going to weigh in on the fact that heat can be used multiple times. So anyway, just kind of keep going through this work stream here. There's some definitions, and then we have a couple. One of the proposals we have before is recommendations for BIM definition and detail content of vendor solutions. If you're an engineer on this call and someone hands you a chiller plant or a centrifugal chiller or something like that, the amount of time it takes to model that could be 8 hours or more of valuable time. And the reality ends up being, why do we just do it once or have everyone do it? Why don't we mandate or encourage vendors to start with LOD 350 content? Okay. The reality ends up being organizations like Schneider is already doing that. And so if we can encourage all vendors as part of OCP and say, this is a recommendation for OCP, then that could make it easier to start building things better. We started talking about coolant loops, and here's where, some of the discussion on CDUs. We haven't yet added the discussion that I had before. We started briefly talking about three-way valves. We have this little discussion here on the trade-off. And in most situations, if you're transitioning between one loop to another loop, you're going to want to use a CDU because of isolation, delta T, delta P, and there's a lot of things you can't do with a balancing valve, and I think that was brought up before. But if all you're looking is trying to do is elevate temperature or separate temperature, it can be done, and it may be a situation, and the person to talk about this most would be like John Musilli, who is one of the senior engineers at a Critical Project Services and used to manage Intel's mechanical on their data centers. And he's been my consultant to a large extent on this, and he's delivered those kind of solutions. I have not. Any questions so far? Is this these topics of interest so far?
For me, yes, especially the BIM one, because I think nowadays we're going to build more and more using digital twins using the BIM. So as you mentioned before, to get kind of details from our vendors in the BIM model, sometimes they don't have it, though some vendors does has it. So I think it makes sense for us to try to mandate this to the end vendors. It makes BIM modeling, creation of BIM modeling much easier. I think so. Yeah. Right.
Yeah, I think that also needs that needs to strike a balance on the BIM level of detail, especially if we're getting vendors of putting more detail in the fabrication level of detail into a design model. They actually slow down the designer's ability to design the drawings. So that we have to strike a balance there, and especially in some of the APAC region, the Revit capability might not be up to the speed in let's say in EMEA and US. So there will be some investment from the owner side to upgrade their hardware just to comply with the BIM level of modeling. So there's some consideration on the owner side and design team side also.
Okay.
So I greatly, and that's the kind of discussion we're looking for. And this is, everyone here should have received access to the link to this document. And OCP is not Don Mitchell. And so no one's going to follow Don Mitchell on this discussion. But if people come in here and make comments here and look through, here's what John Gross actually wrote up on, because he's actually was one of the guys who's been assigned to do an LOD 350, or in some cases, owners have come to him and say, I want LOD 400, not knowing what LOD 400 means. And when he explains the price challenge of LOD 400, which is kind of tied into what you just said, sometimes people bend it. That's why LOD 350 kind of came into being, is the compromise between the definition levels of one or the other. But to this point, if people were to look over this document, for example, critique it and put comments, then that is one way that we can socialize this input and make something hopefully productive over time. And that's the purpose of this call. Because ultimately, OCP doesn't dictate requirements. The community develops a guidance of what they want, and you end up with a
But let me ask you a question. Let me ask you a question. We're talking about this BIM model. We're talking about ones that is for the manufacturer, isn't it? So, correct? That's at a manufacturer level, right? They do it basically. I feel do it once because they have to do it. Use it during the manufacturing process, isn't it? Why would that add a lot of bandwidth to them? Just curious. That's all. I was thinking maybe.
What I'm seeing is quite often their manufacturing models are in SolidWorks or in Inventor or something, and like was mentioned before, they're incredibly detailed, and what we need them to do is usually export it or create an LOD 300 or 350 usable model, which really is just interfaces and connections and that's what I'm often seeing, is that we're getting these giant blocks, families that have just every nut and bolt in them, and kills the Revit models, right? So I think, I mean, look, that is a challenge, definitely.
So if you look at, go ahead, keep going.
Yes, sorry, I agree. So coming from a vendor perspective, you're right, Josh. We tend to sort of throw large, huge, detailed files over the fence, and it becomes very awkward to use. So a lot of the Revit modeling we're doing now is obviously focusing on just the interface aspects, as you talk about, which is the critical things. It's the pipe connection sizes, it's the electrical elements, it's the things that are important to put this into place, as opposed to how it works. So good point.
It's something we do. I'm sorry. Something we do need help on is also show the clearances, so that in the designer model, that not only the interface, but also understand where the clearances are, that we can document on those drawings as we plan our data center.
Good point.
But just coming back to the equipment we're actually talking about, this is like the CDU units. Like this is the equipment related to liquid cooling, not just. That's what we're talking about here, Don. Is that right? Or you're talking about a much wider. Sorry.
No, the focus of my team is looking at how to make it easy to plug in liquids and liquid distribution. Okay, I do appreciate that every time you plug in a 500 megawatt or 500 kW, or 1 megawatt liquid loop, somebody has to plug in, 1 megawatt of electrical power somewhere in the equation, okay, plus whatever it takes to run the pumps for the liquid loop. But we're just trying to address the issues. This kind of shows how we went from this, and actually what happened here with this three-way temperature valve is we had a discussion about CDUs, and John Musili said, well, for that particular application, we could just use a Belimo three-way valve. But the next thing I did is had Belimo show up on the call, and they started talking about, now we don't, what you're seeing here obviously is somebody's product, but you don't see any logos or names on it and things of that nature. So we kind of went through some designs here and things of that nature. But back to the concept here, we started looking a little bit more of when you'd want to use one or the other. And the coolant distribution unit is a fantastic device, but it does have maintenance required. It does have space required. It does have complexity, and it does have cost. And so then the trade-off you have when you look at a CDU is, have you accommodated all these things? And if that's what you need, then you need to accommodate them. I don't know. I think I kind of went off on a path, and I may not be answering your question. Was there a question?
No, that's fine. I think look, everybody here is pretty aligned that we need the vendors, and hi Mark, good to hear from you. Yeah, that the vendors need to have a fully functioning BIM model, which is everything from pipes and wires and the install down to the actual equipment. What we quite often end up with is just a big rectangle for a cooling unit with no interface. It's a big dumb box because we don't get what we need. But yeah, I think if everybody presses on their own relationships, that'll help drive the industry.
Well, and so to that extent, one of the things that you need to be doing is, if you are planning on, trying to accommodate or use a reference design, you have to have some sort of space concept, if you will. And my exposure to this is pretty much everything that my company makes is modeled at a BIM LOD 400, so it makes it very easy to do the pipe work. You can snap it together. But and to the point that AC was bringing up, if you're working with a raised floor, you definitely need to know how much space you're going to need, because you may not have a 6-inch pipe run. And one thing you may find with a raised floor is, if you can raise the temperature above dew point, you may not need to insulate that pipe run. And taking insulation off the equation reduces cost dramatically, reduces space, reduces installation time. And so that might be a reason. For that reason alone, you may decide, hey, I just want to bump the temperature up on this little loop here. And you may want to dedicate a CDU for that, or you may not want to. Either way. I'm trying to keep this void of agendas, and here's one of the ways I try to do that. We have these committee groups. John Bean used to be the head of Schneider's Thermal Products Group. These are some others that are. Jorge Padilla is with a company called Google. Trying to think, Pat Giangrosso is also, I think, with Jacobs, as I recall. So these are people that have kind of contributed to the connection guidance. And we're continuing to try to build that committee because, like I say, we have to grow by consensus, not by one or two people having a really good idea. The CDU heat exchanger guidance. We've had some of the leaders. Cosimo is with, and you got Alpha Laval. You've got Boyd. You've got several others. Furtive and others are contributing to those solutions. And this BIM design concepts. We have Matthew Winter, who's with Global Switch. John Gross, Valley Sorrell is now with Microsoft. He used to be the director or the VP for Siska Hennessy. John Minash. So the concept on BIM design has been discussed greatly, and all the issues you're bringing up, the difference between doing something in SolidWorks, which can be a very beautiful piece of art, but is just cumbersome to try to use for fabrication. And so that's what we're still working forward. And the heat reviews, I haven't launched that committee. It's going to happen sometime, but it's more than I can carry right now. Real quick on pipe connections. It's kind of surprising what we're looking at here. This is actually the pipe connection recommendation is something that is strongly being encouraged by the cloud providers, okay? Organizations like Google and Microsoft, they would like to be able to roll in liquid-cooled IT and pull it out the same way they roll in air-cooled IT and pull it out. And to that extent, standardizing or having a minimal number of decision points on connection is something that's been going through different committees. And what you're looking at here, for under 2-inch, the recommendation was kind of surprised me, because I think when I last had this call, we were talking about BSPP or BSPT, because the guys down under know how to spell that. But the reality ends up being that we're looking at metric. What are your thoughts on the term metric thread? Anybody have a feedback on that?
Works well for us down here in Australia.
Okay. Well, what we're finding, and we even went so far. One time, we were still accommodating the guys up in the United States with this NPT. But the thought here is not that. One of the things we would say is, in many situations for these smaller diameters, let's say 1 inch or 1.5 inch, people may elect to use a quick disconnect. The problem is there is no global standard quick disconnect that is open or not intellectual property. But one thing pretty much all the quick disconnects have in common is they thread in to the pipe. So if you want to use a quick disconnect, then all we're saying is that somewhere on the connection point, you can use 1 inch. And then if Google wants to use metric, and then all around the world, Google knows to order the same dimension quick disconnect, because they all know it's going to be a metric female thread on the immersion tank. Once you get over 2 inches, then over DN50, there's not a lot of common solutions, and groove couplings, and by this we actually say mission critical groove couplings, in terms of something where quality control and installation performance and design characteristics have been rationalized and defined. And obviously, for those that know me, that I work for Victaulic, you'd say, well, I'm saying Victaulic. But the reality ends up being there's over 50, probably over 100 different vendors of groove coupling products. They are defined by standards. And when properly used, properly installed, properly tested, and verified, their performance of 20 years or more is well documented. And the outcome ends up being most vendors want standardization. If you're making an immersion tank, you really don't care what thread it is. You just want the world to say, I want one thread. And CDU manufacturers, you really don't care what. You just want one common one. You'd love to be able to just make one common fitting versus have to have a connection for every country. So that's where these are going. Any comments on this discussion?
Right. I guess if I could just jump in there, I mean, if I look at it from just looking outside this type of product to just crack units or anything else, you've got sort of, imperial metric straight pipe, you've got flange connections, you've got parallel or threaded connections, and they're all very vendor specific. They're all industry acknowledged, but there's nothing that says it shall be up to 100 kilowatts, this type of connection. It just becomes whatever is reasonable to expect and whatever the market generally accepts. So it's probably not an easy one to answer what should be the best way of doing something, I would think.
Well, all we're looking for is the final connection section. When I say the final connection, what we're looking at is trying to help the vendors of the product to actually figure out how to connect their product to a pipe. Now, how you put the pipe together is up to everyone's choice. But what they're looking at is one common point. So if everyone who made CDUs, if the feed was under 2 inches, it was using metric thread. If it was over 2 inches, it used coupling. It would make the process of exchanging devices very quick. Now, let me put a footnote on this. This is not a fully baked discussion. I do tell you right now that the engineers from Google are very interested in completing this discussion. And when I say the engineers from, there's two people that counsel me from Google that both are PhDs. One's this Jorge Nadella, and then the other is a Jeremy Rice. And in their world, they really don't care what the connection is as long as it's standardized and it's not going to leak. And they would like to be able to have, no matter if they go with a Submer tank or a Green Revolution cooling tank or anybody else's tank, if it's using a 1.5 inch feed, then it will be metric, so they don't have to take a guess what I was out on the fly. So anyhow, I appreciate we're getting toward the end of the discussion time period. Is there anything, the closure on this, if you will? We're continuing to develop this stuff. Every week there's some discussions going on. Any insights on how to share this with people in the future in terms of the Asia Pacific group? Is this a good forum? Is this a worthwhile discussion to share? Or should, what are your thoughts on where this is going? Take it around the room. Ken, any thought?
I'll jump in quickly. I think this is the first session for me, and I found it quite informative and helpful. It's obviously, there's some background I need to look into and delve into it, but I think it's a great forum. It's yeah, it suits me, but obviously I'm only one of many. But yeah, I think it's great.
I appreciate that, Mark.
I think it will be actually useful if we actually identify specific tasks and get people to volunteer to actually take up those tasks, and then maybe within a certain time frame we can actually come back and see the progress. I mean, I'm certainly aware that everyone actually have their formal job to do, but this is actually extremely interesting, and I think it's like then we can actually see the progress, because I'm just concerned that if we like keep it open, I don't think we like there's a possibility that we're not getting anywhere.
I appreciate that, which is why I've broken out these subcommittees, and I am going to try to keep pushing forward. It has taken a certain amount of time just to socialize and understand where we want to go, but I think we're getting there. And now we just need the people to help write it as something that is a clear guidance. But who else? Josh, did you have any insights, or did you already speak?
No, I haven't, but I know I was about to say that I'd like to sort of socialize this with our design consultants, but then I realized that Ken Ma is one of our design consultants. So really, I think that's what great to hear from you, Ken. So I think that's the key thing, is to spread the you know, the understanding of like what is the scope of this, what are the different types of technologies, and then what, maybe not contributing so much, but you know, understanding that when somebody asks for it, where is the pool of resources to go to, you know, to find out how things can be done. So yeah, I mean, I think that's basically where we'd like to go from this, is yeah, socializing with our design consultants.
Okay.
So yeah, that's great. Hopefully, Ken, you can share it all with the Arab team. It's saved me a lot of work.
Yeah. Serene, any insights on this? What are your thoughts on this?
Hi, hopefully you can hear me clearly this time round.
I hear you. Yes, you're coming through great.
Okay. I think I have a similar situation here. First time to join this platform. Very informative and good to have all these sharings and understanding what is on the market for the latest trend.
Okay. Well, it's only going to work if we get collaboration and agreement, and also if we get opposition in terms of if if there's something you're seeing here that is sounds like it doesn't make sense or has an agenda, then it's not going to fly. If you feel, and that's where the big work we need to do is first coming up with where we want to go, and then defining it and describing it in a way that people realize it was actually thought through and not somebody just waking up in the middle of the night trying to do something. So Serene, your insights are fantastic. Appreciate on that. Darren, any comments? Or I don't want to hate to jump the little spotlight around the room here, but
No, don't. Good stuff. Good stuff. I've been following OCP for a while now, so it will be interesting to hear more what's coming up, fairly quickly, next couple of months, next couple of years, so that we could, allow our design to accommodate for the changes.
And Darren, who are you with?
I'm with Serene. We are from DLR.
Oh, okay. Yeah. No, I appreciate that. Sorry, I remembered Serene there. Jayan, is that how you pronounce your name, sir? I don't know. I probably didn't do it well. So anyhow, what I would like to do is I will send a follow-up on here and attach this PowerPoint on where we're going as kind of a set of notes. As I mentioned, all these calls and the calls that we do weekly, back in, when I say back, they're done at 0800 Pacific time or 1100 East Coast time, 1600 in Europe time, and I think around midnight in Singapore time. You're invited to join. But if you don't want to join, you can go online. You can play back, and most times we try to record those. And that's the key aspect of this, is just to make sure people realize that we're actually socializing these discussions. They're not just today. You just had me speaking, but normally at these calls, there's 5 or 6 people much more senior and experienced in design than I am that are contributing to these discussions. And we are making, there's a significant progress in that aspect, but it takes a while to get it all documented. I'd like to highlight here, we've got Melissa online from Belimo, she was very helpful in talking about 3-way valves. That's an example of where a topic came up. One of the speakers specifically highlighted using a 3-way Belimo valve, so we invited Belimo to the call. Say hi, Melissa. Hopefully you're still there, or she may have walked away.
Hi, everyone. No,
okay.
Sorry, I'm juggling kids and dinner time too.
Oh, sorry, I didn't mean to spotlight. Hey, so we've done the better part of an hour. I'm going to go ahead and stop recording. I'll hang on. You guys can chat with me if you want.